Example 2 in 2.3 for Math 20-1, students typically don't like because they force us to draw the triangle. What I always encourage students to do is not to overthink it. When you draw your triangle, don't make it to scale, just draw a triangle and then start to label it. Now, typically when we talk about labeling a triangle, we label it in the order that they list the numbers. And I usually just go in a clockwise order. It truthfully doesn't matter. Think of it as just rotating the triangle if you put it in a different direction. That being said, once I draw these angles in, that's now that this is 36 degrees. I don't know angle R, I don't know angle Q, but they tell me that side P is 24.8 and side Q is 23.4. Now I'm going to put a lowercase r there, and then I'm going to set up my sine ratio. Now, or my sine law ratio, it says determine the measure of angle r. There's no real reason that you have to use, the side on the top or the angle on the top, but typically whatever I'm solving for, that's what I'm going to make the numerator. So I am going to use the form that sine A over A is equal to sine B, which is on your formula sheet over B, is equal to the sine of angle C over side C. But then I'm going to make it specific to this question. And again, I'm going to plug in the values that I know. So instead of sine angle A over A, I'm going to say that this is sine of angle P over side P. That's equal to the sine of angle Q over side Q. And that's equal to the sine of angle R over side R. And just to make sure we see where those are, this 24.8 is side P, and the 23.4 is side Q, because they're opposite of those labeled angles. So when I put the information into this question, we are going to get a little bit more kind of useful form out of it. And I'm going to be able to say that the sine of 36 degrees divided by 24.8 is equal to the sine, well, I don't know angle Q, but I know side Q is 23.4, and that's equal to the sine of angle R over side R. Now that last term really, really sucks because we don't know any of the information, but there is another formula present here. And it's present for every single triangle. It is that the sum of the angles is equal to 180. And so I want to put that value in just like I did on the other side. That means that 36 degrees plus whatever Q is plus whatever R is equal to 180. And really what this means is that if I figure out angle Q or angle R, I can figure out the third angle. Because if I know two angles in a triangle, I can always use that sum of the angles is 180 to solve for the third. Now, looking at the sine law, it is very important that because this third fraction contains two unknowns, it's not really useful to us. I can't use sine angle R over side R to solve for either, because there would always be two unknowns in the one equation. But if I were to cross out what I boxed in blue, what we see is that this formula is more than enough to solve for angle Q, and then we can go and solve for angle R to the nearest degree. And the way that we're going to do that is with our standard trigonometry. And really what it means is that we have to get sine Q isolated and then solve for angle Q from there. And the way that we do that, I'm going to write it out again here. The sine of 36 degrees over 24.8 is equal to the sine of some unknown angle Q over 23.4. To solve this, I need to eliminate the fraction, or isolate sine Q, and I'm going to do that by multiplying the entire equation by 23.4. That has to distribute onto both sides. I get 23.4 times the sine of 36 degrees divided by 24.8 is equal to the sine of Q, because the 23.4's cancel. And then the last step here is to recognize that that means that angle Q is the inverse sine of 23.4 times the sine of 36 degrees, all divided by 24.8. And that we need to plug into our calculator. And you can plug it in as is, but what I see a lot of students doing, and I really like this technique a little bit better, is what they'll do is they'll kind of work out the inside first and then apply the sine at the end. So the way that I'm going to do that is I'm going to check, make sure that I'm in degree mode. And I really do like the idea of determining the value of the inside expression first. So that's 23.4 times the sine of 36. I'm going to close that bracket, then divide by 24.8. And then once I have that value, I'm going to take the inverse sine, so second sine, of my previous line's answer. And what I get is that angle Q is 33.683. I'm going to write that, and then I'll maximize this again. So I get that based on that work, that's angle Q is 33.683433169 degrees. And then what we know, and it's, you can't actually see it right now, but angle Q plus angle R plus angle P is 180. we now know two of these angles. So I can say that angle R is 180 degrees minus Q minus P. So angle R is 180 degrees minus the 33.683, and I'm going to use the unrounded number from my calculator, minus, I'll put a degree symbol there, angle P, which was 36 degrees. So now I can take 180, subtract the answer that I just got to actually hit that subtraction button though. So second answer, and then I'll also subtract the 36. And I get that angle R, I get that angle R is equal to 110.3165 ... degrees. I believe it said nearest degree, so we're going to say 110 degrees. Now, this is tricky when we talk about doing the sine law, because sometimes you have to solve for things indirectly using the sum of the angles is 180 and things like that.